All right, let's see. Let's see who got it. Luciana, you think you did it? You think you did it wrong. Who thinks they got it? Anybody? If we think of this one as U and this one as V. Okay. All right, so finding the derivative. So what's the derivative of X? I guess I should say what we're on. Sorry, we're doing quotient rule this time. Guys, what do you think quotient rule is going to be? What does a quotient mean? When you divide? Quotient? So probably this is going to be when we have two different functions that are divided, all right? All right, so if we take a look at this, first one here, our bell work, we're doing a tangent line, means we need pot and sot. Part of that is getting the derivative. And so we're going to have to do a product rule like we did last class. The derivative of x is what? Good, it's 1. Do I need to write a 1? No, not necessarily, right? And then it's v, so that's just going to be sine x. Technically 1 times sine x, which is the same. Plus the first function u times the derivative of v. What's the derivative of v here, or sine x? Cos x. Awesome, there's my derivative. But it wants the derivative at pi, so my next step is to go ahead and plug in pi into that. So then I'm going to get sine of pi plus pi cos of pi.
Wait, you're going to
Am I? And then you guys got to look at the unit circle. Tell me what sine and cosine of pi are. Yeah, so sine of pi is 0. And cosine of pi is -1. And then the more simple way for us to write that, of course, is we don't need to bother with this. And let's rewrite this as negative pi rather than pi times -1. Because if we leave it like that, someone's going to write pi minus 1. And that's wrong, right? It's negative pi because they're multiplied. So there we go. Now we got our sot. So our sot is negative pi. Our pot is obviously pi and something. I need to plug pi into this original one. And we just said, what was sine of pi again? 0. So therefore, 0 times anything is still just 0. So there's my pot. Once I have pot and sot, what's my next step? Martine. Martine, your voice is so soft and gentle. Luzanne, what do we do?
We plug it into the y.
Yeah, y minus y1 equals m x minus x1. Exactly. So now that she helped you out, Martine, what do we do, buddy? Don't sigh. What's y1?
Y1 is
If you look at your pot, what's the y?
pi.
No, that's x. 0. There you go. Do I need to write y minus 0? No, it's not wrong if I do, but I don't need to, so we'll just go straight to the slope. What's the slope? Martine, your voice is just so soft, buddy.
Why are you asking me all the questions?
Because you seem like you're not here this morning. All right, Jose, what's x1?
Pi.
Yeah, there you go. So this is just negative pi times x minus pi. There's the equation of my tangent line in this case. Remembering last couple classes a little bit? Uh-oh. You might have to go watch the video then, guys. You might have to go watch it. All right, so now what we're going to do is we're going to do a quotient rule, and just like last time, we're going to solve it 2 different ways. The first thing we're going to do is we're going to simplify it, make it look like a polynomial, which is the way we did it previously, so that we can just use power rule. Then after that, what we're going to do is we're going to solve it using quotient rule, and I'm going to show you it's the same thing. Okay? Okay? So to make this look like a polynomial, you'll remember the first thing we did is we just rewrote it as like 3 separate fractions all over x squared. Because if the common denominator is x squared, there's nothing wrong with me putting them together or taking them all apart. It's just the common denominator. Does that make sense? Do you guys remember that? Writing these all as separate fractions, yes? Welcome, Raquel. All right, so f prime is, or sorry, not f prime, just f. All right. What is 2x cubed over x squared? 2, and then what happens to x cubed over x squared? Just x. And then we've got x squared over x squared. What happens to those? They cancel out. So I've just got -3. And then this one is like 2 over x squared. So remember, this is where we use that exponential trick or exponent laws, and we write it as x to the negative 2, right? Cross the line, flip the sign. You guys remember that? Yeah? Good. So now it looks like a polynomial. Now I can take the derivative real easy, because in this case, right now I'm just using power rule. The 1 comes down and it's 2. The x goes away. The derivative of a constant is 0. And then the negative 2 comes down, multiplies by the 2, so negative 4. X, subtract 1 from our exponent, and we get negative 3. Careful with the negatives, right? Inevitably, students like to go negative 2 minus 1 is negative 1, but that's not true. Negative 2 minus 1 is negative 3. Okay, so careful with when you're subtracting from a negative. And then you're pretty much done, right? There's nothing else we could do. Maybe you want to write it with like a positive exponent like this, but those are both correct. I would accept either of them. I don't really care which way you do it, unless I specifically say write it with positive exponents, in which case you better show me the second one. Yeah. Yeah. All right. So that's how we found it using our old method. In this case, that's not too hard. But let's go ahead and let's write down what these two gentlemen smarter than us figured out a long time ago. So Leibniz was the first to publish this one. And for this rule, if we have h of x is equal to f of x over g of x, then what that tells us is that h prime of x is going to be equal to, and it starts off very similar to product rule, f prime of x, g of x, minus, instead of addition, f of x, g prime of x, and then this extra part is it's all over the bottom one squared. Now I understand that that's a little bit hard to remember. It is written on my wall. I'm also going to give you a little bit of a, I don't know, acronym, saying, song to remember it. I haven't done anything yet.
No, so I can
But I don't know what I'm waiting for. I haven't done anything.
so I can copy that.
Oh, she's angry this morning. She woke up and chose violence. All right, so if I'm going to say something that says high and low, which one of these two functions here do you think would be high? Which one would be low? It's not a trick question, I promise. Yeah, this one's going to be high because it's on top. This one's going to be low because it's on the bottom. So what we do is we say low d high minus high d low over low squared. Okay, so low d high minus high d low over low squared.
But what does that mean?
Well, low, g of x, d high, derivative of the high, f prime of x, minus high, f of x, derivative of the low, g prime of x, over low squared over gx squared. So it's just a way of helping you remember the order that this goes. The biggest reason is because with product rule, because it was addition, the order didn't matter, right? Whereas this time, because it's subtraction and division, the order definitely matters. You have to get it in this order or it will be wrong, okay? So you got to make sure that you write this one right. So that's part of why we have this little mnemonic, low d high minus high d low over low squared, all right? And again, it is written up there on the big 3 poster as well. Okay, so let's apply this now to that same function that we just did. And let's show that it's the same thing, whichever way we do it. So doing this, this would be my low, this would be my high. So f prime is equal to low d high. Actually, you know what? Hang on. Let's, kind of like we did with product rule, let's write it out over here. So if we do like low and then d low, and then high and then d high. The low is just x squared. What's the derivative of x squared? Not a trick question. 2x. Remember, the 2 comes down. Okay. High is 2x cubed minus 3x squared plus 2. And the derivative of that, we're just applying power rule. 3 comes down, 6x squared. 2 comes down, minus 6x. 2, there's no x, so it just goes away. It's a constant. Derivative of a constant is 0. So now we've got those written out. So low, d high. We need the derivative of the high, which is 6x squared minus 6x minus high. I'm going to write out the entire high. So 2x cubed minus 3x squared plus 2 times d low, which is 2x, all over low squared. So x squared squared. What is x squared squared? Really? Where can I simplify that to? X to the power of 4, right? We multiply if we've got those. Okay, so now what I need to do is I need to distribute these so that now normally I could just be done, but in this case I definitely want to show that it's the same as before, so we're going to multiply it in. So 6x to the 4th minus 6x cubed. Then I'm going to distribute the negative 2x into all of these. Get negative 4x cubed. Sorry, to the 4th.
We need to do that. Or
Yeah, we're gonna do this just so that we can see it's the same. I won't always make you do this, but in this case I do want you to. This will be plus 6x cubed minus 4x all over, we already said, x to the 4th. Now, does anything cancel there?
negative 6.
Yeah, 6x cubed and negative 6x cubed definitely cancels. And then I can put these two together to be 2, because those are like terms. So that would be 2x to the 4th minus 4x all over x to the 4th. But instead of writing it as x to the 4th as like a single fraction, remember we can always write it as two separate fractions. So what we're going to do is write it like this, only for the purposes of, again, showing it's the same. You don't normally have to do this, but I want to show you it's the same as what we did before. Here, the x to the 4th cancels. What happens here when it's x over x to the 4th? What does that become? What do you do when you're dividing? Do you add, subtract the exponents, multiply the exponents, divide the exponents? Subtract. So 1 minus 4 is? There we go. And if you look, isn't that exactly the same as what we got before if you look up? Same as these, right? It's the same thing. If we look up at the previous one that we just did, right? 2 minus 4x to the negative 3. So it's the same. Now, again, just like product rule, you might kind of say to me, okay, but why? Like, isn't it easier for me to just turn it into a polynomial? Yes, but what happens if I can't? What if there's like a trig function, right? Or something that's really complicated where maybe turning it into a polynomial is a lot of work. Then that's when it's probably going to be easier to just use this quotient rule. So, all right. In this one here, if we can factor things, it usually makes our life easier. So let's take a look at doing it that way first, and then we'll take a look at some examples where we have no choice. We have to use quotient rule. So if we factor this, what does that top factor into? What's it going to be? I need to multiply to 2 and add to 3. Nicholas, man, come on. What is it?
What was that question?
What multiplies to 2 and adds to 3, guys? There's only like, yeah, there's literally only one answer. So it's x plus 2, x plus 1. Okay? What about when I factor x squared minus 1, a difference of squares? What's that one? A difference of squares. That means it's take the square root of both, add and subtract. What's the square root of x squared?
X.
Just x. What's the square root of 1? Guys, it's really not a trick question. What's the square root of 1? It's 1. So it's just x minus 1, x plus 1, right? Because when we do it this way, the middle term disappears. That's the beauty, I guess, of a difference of squares. And then you'll see, oh, this cancels out. And so our f of x simplifies to be x plus 2 over x minus 1. And then if we do our quotient rule, it's a hell of a lot easier. So let's do that. So if we actually apply the quotient rule now, it's going to be a lot easier, right? Because if we look at here, what's the derivative of either of these things? What's the derivative of x plus 2? 2 goes away, it's a constant. So what's the derivative of x? 1. What's the derivative of x minus 1? 1. So you can see how this one's going to be a lot easier, right? Because now if we take the derivative of this, it's low d high, which is 1. Do I need to write that? No. Minus high, make sure you use parentheses, d low, also 1. Don't really need to write that, over x minus 1 squared. Now, we might as well go ahead and simplify that a little bit. So what's x minus x? It's not a trick question, guys. What's x minus x? You are so asleep this morning. Let me make it easier for you. What's 4 minus 4?
0.
Yeah, so what's x minus x? 0. Okay, there we go. Thank God. All right, what's negative 1 minus 2? Be a little bit more careful. Negative 3. So it's going to be negative 3 over x minus 1 squared. Okay, so if we can factor, just like before, you probably should. So, right, what did we learn about like our algebraic analysis above? If you can factor, do it. And this is pretty much the case for all math all the time. Right? If you're able to factor something and make it simpler, you probably should, because it's going to make your life easier. Does that kind of make sense? Man, did you guys party last night? Like, you're already getting like the shortest week ever. What time do you guys leave tomorrow?
Sir, do you have any students this week? Like that are staying?
I have no idea. There's usually 2 or 3.
But you still come to school?
I mean, Marco shouldn't go, but he's gonna go, I'm sure.
You still go to school? Come to school or you?
Yeah, I still have to be there. Yeah, they have me do other things. Is Marco going?
Yeah. And he did a crazy.
Can you do me a favor and try to protect him a little bit?
Oh no.
Please don't make him like wreck his knee.
He's gonna get crazy.
I know he's gonna destroy his knee. All right. Anyways, yeah, I don't know. Are all of you guys going? Except for Antoine, of course, because he's in grade 10. The rest of you are going? All right. All right, so let's use the quotient rule now to derive a couple of these things. You don't have to ask me. If you're not allowed, I'll tell you to come back, man. All right. So you guys, in order to do this one, I need to rethink about what tangent really is. What is tangent really? If we break it up into sine and cosine, what is it?
Tangent is
I'll give you a hint. It's right behind sleeping Maxo. Oh, wait, is it there? Maybe it's not there. That just tells you the derivatives. And I thought it's trig identities, but it's not the right one. Oh, yeah, I don't see it. Anyway, it's sine over cosine. Sine over cosine. I thought it was there.
No, yeah, he was.
Oh, it is okay. You better actually go, man. All right. So now if I want to find the derivative of this, then I can use the quotient rule now to figure out what is my derivative of tangent. Okay. Now, truthfully, you guys, this is annoying enough that most of the time you'll probably end up memorizing it even just by accident because it's not a very hard one. But for now, we're going to prove that it is what it is. So if we do low d high minus high d low, right? So remember, it's low d high minus high d low over low squared. So let's move this part down a little bit. That means that it's low cosine d high. What's the derivative of sine? Cosine. Right? Derivative of sine is cosine. Minus high sine. D low. What's the derivative of cosine? Negative sine. It's probably easier, you guys, if we just put this negative out front right away and turn that subtraction into an addition. Would you agree? Like negative times negative is positive. Let's just put the negative right out front. Okay? All over low squared, which is cosine squared theta. Now, allegedly, you learned about this wonderful identity. And we're going to see it right here. What's cosine times cosine? Again, not a trick question. Cosine. What's x times x? X squared. So what's cosine times cosine? Cosine squared theta. There we go. Plus sine times sine is the same. Sine squared theta. All over cosine squared theta. What's cosine squared plus sine squared? It's this beautiful identity you allegedly learned about.
Why do you put parentheses?
Around the theta?
But not,
I did. I put it around every single theta. Oh, why did I put them here?
no, the side squared.
Oh, I should have put them in both.
Yeah, I mean that on top. Why did you put double?
Well, because cosine times cosine is cos squared.
No.
Oh, here? Because technically, remember, this is negative sign, so I was going to put it there, but then we talked about how it's easier to just move that negative out front.
So it will be negative sign.
Yeah, like the derivative of cosine is negative sign, but if we're subtracting negative sine squared, that's the same as just saying plus sine squared, right? Now, guys, look behind Maxo. What's that identity that's written there at the top? Right behind Maxo. Sine squared plus cos squared equals 1. It comes from the unit circle. So this means that it's really just 1 over cosine squared theta, right? Because cosine plus sine squared is 1. Excellent. What's 1 over cos squared? I think this one's written over there. Maybe not. It is secant squared theta. Yeah. Oh, well, good thing it's written on the wall right there.
What's secant?
See how it says d dx of tan x is equal to secant squared? Secant is just 1 over cosine. So, like I said, I'm not going to expect you to derive these all the time, even though you can, but let's write down what they are. So first of all, we had that d dx of tan x, so the derivative of tan x, is really secant squared x. d dx is just another way to write derivative. Okay, so this means take the derivative of tan x, it's, secant squared. Then I can look at what all these are. So if tan was secant, cotangent is going to be cosecant squared x, sorry. Should be x. However, it is negative. All right, so there's a negative cosecant squared. These are all written on the wall for you anyway. Secant is tan x secant x. And the last one here is cosecant, which is negative cotan x times cosecant x. Okay, I do not expect you to memorize those. That's why they're written on the wall, so that you can use them. Right there. All 6 of them are written there. And I think most of them are written down over there as well on the yellow one. Girl, we need to get you glasses. More than 170. Oh my God. This girl's going blind.
Is that a C or an S? C-O-T.
C-O-T, cotangent. Man, you guys have not learned trig. You have not learned trig.
No.
I know. You saying I'm horrible?
No, but like the preparation.
All right. Let's take a look at putting this into practice on a couple of equations, okay? So we're going to apply quotient rule to these 2 equations. You guys want to do trig first, or you want to do polynomials first? All right, let's do the polynomials, so the rational expression. This is obviously my low. This is my high. Let's just quickly write out what the derivative of those are. So what's d high? What's the derivative of this top one?
2x.
Minus 2. Yeah, girl, you don't have to ask. D low, what's the derivative of x plus 2? It's a nice easy one.
1 plus.
Just 1. Because the 2 goes away. So now we can find the derivative doing low d high minus high d low over low squared. So low, x plus 2, d high, 2x minus 2, minus high, x squared minus 2x, d low, that's 1, all over low squared. Now in this particular case, if I multiply these all together, it simplifies a little bit. But the truth is, you guys, in this particular class, I'm not going to force you to simplify them all the time. Once in a while, I will tell you, hey, simplify this. Or if it's a very simple simplification that makes it way easier, then you should do it. In this particular case, it's not super easy. It's not super hard. Let's practice it just so that we can see and so you remember how. So what do I do to multiply these two binomials? What am I going to do? Emilio, what do I got to do to multiply two binomials, man? There's an acronym that helps you out. I think even in Spanish they use it. What? FOIL. First, x times 2x. That's 2x squared. X times negative 2. Well, that's negative 2x. Insides, 2 times 2x, that's 4x. Outsides, 2 times negative 2. And then this one, I just distribute the negative in. So minus x squared plus 2x. All over the x plus 2 squared. Now, I can put a bunch of stuff together there. What's 2x squared minus x squared? What's 2 of something minus 1 of something, guys? Nope.
1.
Just 1. Doesn't fully disappear. It's just 1x squared, right? 2 of them, and then minus 1 of them, there's still 1 left. Now, negative 2x plus 2x, those cancel. Might as well just write that out to make it easy for us. So the only thing that's left there is the 4x, so plus 4x. The negative 4 is by itself. And so we get this. And I cannot simplify that further, so that would be my final answer. Yeah? Any questions about that, or does it make sense?
Can we get a 5-minute break?
After this page. Yeah. All right, let's do this one. P of theta. All right, so this is obviously my low. This is my high. Let's write down what the derivative of those two things are. What's the derivative of theta squared? It's the same as what it was for like x squared.
Theta.
2 theta. 2 theta, right? The 2 comes down in front. All right, and yes, you were right here. Luciana, you had said sine. This is cosine. You're correct. Cosine theta. Then we can go ahead and write it, because remember, we've got low d high minus high d low over low squared. So let's go ahead and write that out then. So low is just theta squared. D high is cos theta minus high sine theta. D low, 2 theta, all over low theta squared squared. And the only thing I can really do there is I could simplify this, pull out the one common factor. What's the common factor in the top, in the numerator there? What's in everything? I'll put in those brackets. Yeah, theta, exactly. So I could pull out a theta, which would give me theta cos theta minus 2 sine theta, all over theta to the 4th. Can I cancel out one of those thetas now? Yeah, right? If I have a theta over theta to the 4th, I can cancel 1, and this just becomes a 3. So the bottom is now just theta cubed.
Wait, what? You cancel theta and theta, so it becomes theta.
Because then on the bottom, it becomes just theta cubed. All right. I'm going to zoom out a little bit. Sorry, Modest.
What?
I said sorry. All right, guys, let's take a look at this one. So remember I said we were going to look at some examples again where like we have no choice. We have to do quotient rule. You can see here that f of x, first of all, is a piecewise function, right? Because it's got like three functions there. Second of all, it's got a cosine, and there's no way for to make this a polynomial. It's absolutely impossible. So what we need to do is we need to work it out, find the derivative. Then it asks me here for using quotient rule, I should say. Then it says find where it's increasing and decreasing. How do we figure that out? How do we know? It's on the blue poster. Yeah, if it's positive, it's increasing. If it's negative, it's decreasing. What happens if it's zero? It's a critical point, something, right? So it's not increasing or decreasing. So what we need to do is find the derivative, plug in pi, and then interpret what that means, okay? So let's go ahead and do that. Let's start by just writing out what the derivative would be. So r prime of x is going to be low f of x. D high, what's the derivative of cosine again?
Negative sign.
Negative sign. So we got to make sure we put that one in parentheses so we know it's multiplied. Minus high, that's cosine. D low, f prime of x, all over f of x squared. Okay? Now from there, we need to figure out what sign the derivative is at pi. So the key here, guys, is to realize I just need the sign. I don't need the exact value. It's not asking me what the derivative is. It just wants to know increasing, decreasing, or neither. So that means that when I'm finding r prime of pi, I don't need to know if it's like negative 4. I just need to know it's negative. Okay? So if I put in f of pi, which makes sense here because pi is like here, can I know exactly what that value is? Like, no, because pi is hard to look up. So unless I'm using a calculator, I can't. So all I need to know is the sign. Is this positive or negative? It's negative. So I'm going to go ahead and say that that's negative. Now, what is sine of pi? We did this. 1. No? 0. So negative 0 is just 0. So this is 0. Minus cosine of pi. What's that one? Not 1, but on the other side, it's negative 1. And then I need f prime of pi. Now, this is probably the trickiest part on here. If it is f prime of pi, that means I need the slope. So if I look here, it's at the same point, but I need to know the slope. What is the slope of that line? Is it positive or negative? It's negative, right? It's a negative slope going down from left to right. So I'm just going to put that it's negative. And then I'm over f of pi squared. The truth is, if it's squared, what is it automatically? Positive. It has to be positive. So now what I have is something times 0, that goes away. Minus negative times negative, which is ultimately what? Well, 2 of them is positive, but then if there's a third one, it's negative, and it's over a positive. So ultimately, what is this derivative? What sign? It is negative. Therefore, we can say r of x is decreasing, or you can write out decreasing. That's what that means. Decreasing at x equals pi. And what's our reasoning? Because why? Because the derivative, r prime of pi, is less than 0. Or you can say below the x-axis or negative. I don't care how you say it, as long as we somehow point out that the derivative is negative. And that's why we know that this original is decreasing. Does that make sense to you guys? Yeah? Excellent. Do I have you guys tomorrow or on Monday? Tomorrow. So the day that nobody's here. I guess that's, I don't know if that's better or worse than the day you're all hungover. So here's what we're going to do. Guys, okay. The next class is, listen. The next, normally I would give you a break and we could stop here. But guys, you're not going to be here, most of you, tomorrow. So that means we're going to finish this lesson. Tomorrow is a work period. If you happen to not be here, that's on you. You work whenever you feel like it. No, girl, we have one to do together, and you have two, which you technically have tomorrow to do. You're just going to choose not to be here.
No, none of us.
And they showed us like an email that we have to be 1325.
But it's not that we're going to choose Mr.
Don't even. You're choosing it.
No. It's because that's 12th grade.
Yes, I know. You're going to go sing to some little kids.
Yeah. All the days.
I know. That's why I'm giving you a work period, so you can still do it. Don't worry about it, guys. All right. Absolutely not. We got 20 minutes. We can easily get this one page done, and that way you've got next block when you're not here to not worry about it. I can't leave it, guys, because realistically, especially you grade 12s, you guys are not here for the next two classes because you're not here tomorrow and you're not here next Tuesday. So I can't do that because next Tuesday you guys have a simulacrum. So I can't. We have to finish this one. Okay. All right. So P prime of. They want to know P prime of 4, and they want to know what the original graph is doing then. So that means I need to basically just find the sign of P prime of 4. But in order to do that, let's find P prime of X first. Okay? And it's just low D high minus high D low. So low minus D high minus high D low. Right? I'm just going through and applying the rule. Yes, you do.
How do you know when to use that?
Or product rule? Product is when two things are multiplied, and quotient is when they're divided.
But you will ask us.
Not always. Sometimes I'll just say take the derivative. Yeah. But it's quotient. They're in the name. Quotient means division. Product means multiplied. Okay?
So like you will tell us like you quotient.
I will for some, yeah. But not always. All right, then I need to actually plug in what these things are. So P prime of 4 is going to be F of 4, G prime of 4, minus G of 4, F prime of 4. And then you're going to remember why you love these kind of questions. Because they're so easy. Because now all I need to do is I'm just going to look up here at this chart. Okay, so I don't want to scroll up and down. I think that'll be, well, I'll scroll up and down a little bit. So for F of 4, I just scroll up, I look at the chart. Here's 4, here's F, what is it? 1. Right, I'm just going to read it right out of the chart. So F of 4 is 1. Because it asked us to find it at x equals 4. So then I need to find G prime of 4. So again, if you look at your chart, G prime of 4 is what? Not 7. That's G of 4. We're looking at G prime. There you go, minus 2. And then G of 4, we already said is 7. Okay, F prime of 4, I'll scroll up again just to make sure you're getting it for the video here. So 4, F prime, they meet here at 8, therefore that's my answer. So I put 8. We already did F of 4, it was 1, so it's over 1 squared. All right, 1 times negative 2, negative 2. 7 times 8, 56. Over 1 squared, well, that's just over 1. We don't need to bother. And so in the end, P prime of 4 is equal to negative 2 minus 56, or negative 58. What does that tell us? P of 4, yeah, decreasing, exactly. P of 4 is decreasing because P prime of 4, that looks like 9. Exactly, it's less than 0. Perfect. Great. 2 more. You can do it. Hold it together. We can do this. I believe in you. So, when these things get, let's say, hard, it means we have to combine the rules that we know. So what do you notice about Q of X here? There's obviously a quotient rule, f of x over g of x. It also has 2x2, so that means there's a product. So this is a product rule and a quotient rule. It is both, okay? So if we do this one, you might say, what order do we do them in? We do them whenever we encounter them. So for product rule, we take the derivative of the first term. That's going to be 4x. We multiply it. Yeah, that's a Q. but we multiply it by the second term. Okay? Then we add the first term times the derivative of the second. This is where I'm going to put a big set of brackets because now I need to do a quotient rule because the derivative of a division statement is quotient rule. So this is where it's exactly what we had before. It was g of x, f prime of x, minus f of x, g prime of x, all over g of x. Right? We just did that one. And now we're done. Right? The product rule is these two things added. The quotient rule is just this part in the big set of brackets.
G of x squared.
Ah, yeah, sorry. G of x squared. Thank you. You're absolutely correct. Yes. Good job. Good job, ladies. One day Lucas will wake up and he'll do that too. Maybe not. All right. So Q of x. No, not Q of x. Sorry. We want what? Q of 2 here. So Q prime of 2. Now, that means, do you want me to write it out, or are we okay to look up and know that when it says f of x, that means f of 2? Are we okay, or do you need me to write it out? I'll do it either way. We're okay? All right. So, first of all, 4 times 2, that's just 8. What's f of 2 if we look up? F of 2, let's go up. F2, it's 2. And what is g of 2 if we look it up? -1. Good. Plus 2x squared, which is really 2 times 2 squared, which is 2 times 2 times 2, or 8, inside our big set of brackets. G of 2, we already said is -1. F prime of 2, that's a new one. Let's look it up. What's F prime of 2? F of 2, we already found was 2. What's G prime of 2? That one's new. -1. All over G of 2, which was -1 as well. And then we just need to go through and simplify this, right? So we kind of like these chart questions because all we need to do is scroll up and look at whatever value we need, like G of 2 or G prime of -2 or whatever it is. So let's go ahead and simplify. 8 times 2 divided by -1 is -16. And then 8, let's simplify everything in here. -9 minus 2 times -1 is +2. Over -1 squared is over 1. That gives me -16 plus 8 times -9 plus 2 is -7. -16 minus 56, which gives me -6072. So Q prime of 2 is equal to -72. It doesn't ask us, but what would that tell us then about the original? Is the original increasing or decreasing? The original is decreasing. Excellent, guys. Can you hold it together for one more for me? What was that, Martine? Did you say yes?
I don't even know what happened there.
You can do it. You can do it, Martine. There's one more. We believe in you, Martine. All right. Wait, did I get rid of it?
Yeah, we're done.
Oh, I thought there was another one.
No, yes.
No, there is another one.
There is?
No, we're done. We're done.
Oh, we're done.
Yeah.
Look at that. I scared you.
No.
Is there really not another one?
Uh,
We're all